Density functional theory methods are by far the most popular approaches for electronic structure calculations. However, the best functional remains elusive, despite the increasing variety of functionals and continuous efforts to improve their computational accuracy. In our work, published in Advanced Science, we show that the ensemble of the existing functionals are by construction more accurate than any individual functional. These ensembles combine predictions from multiple DFT functionals to yield higher accuracy than individual functionals have. The more functionals in an ensemble, the more accurate your calculations. Among possible ways to construct an ensemble, we adopted one of the simplest ones based on the principle of Occam's razor. We make a weighted average of the predictions by each density functional. The weights are obtained via the regularized linear regression. This approach has several important benefits, such as simple implementation, analytical and fast evaluation of optimal weights, good transferability as only very few weights are optimized, essentially preventing overfitting, easy evaluation of the energy derivatives, and size consistency to the extent the individual functionals are size consistent. Of course, the price to pay is the increased computational cost of the ensembles, but luckily, the speed of the ensembles is not that much more than the best and slow functional in the ensemble. Also, we introduced several practical solutions for speeding up the evaluations with ensembles. We can reuse the density matrix as an initial guess for the next functional SCF, or we can construct the mixed exchange correlation functionals and only perform a single SCF cycle. Importantly, the ensembles produce very stable predictions of electron densities, potentially ensuring the robustness of the approach for predicting the other electronic structure properties. We constructed several series of the ensembles, which we call DENS24, based on ORCA and PySCF interfaces. In the series, for example, based on the PySCF interface, the number of functionals is indicated as DENS24p times n, and you can select the better and more costly ensemble by increasing the size of the ensemble and similarly to increasing the size of the basis set. We implemented the DENS24 ensembles in Emulatum, and the calculations can be performed as described in our online tutorial. We can also use ensembles on the ZEX Cloud to perform online DFT calculations, for example to optimize geometries.